Perfect. Yeah. And we can also hear you all, both Branko and Yiyun. No problem for your audio. And the third speaker is Adrian Gilagos from ASTI.
Hi everyone. Hello.
We can hear you. Thank you. So for the speaker in this session, you have 25 minutes, including the Q&A. So I think we can start the afternoon session now. So the first speaker is Dr. Ariel Blanco from Philippine Space Agency. The first two talks is about the application of Earth observation data. The first one is from Philippines. So Dr. Blanco, the floor is yours.
I can start now.
Yes, if you are ready. Thank you.
Thank you very much to Dr. Franz Leon for inviting to the Space Agency to share on the different applications of SSTA or space science and technology for disaster risk reduction and management. I understand that our friends from PASA will present more details on oil spill, so it's also included in my presentation a little bit now. So I'll discuss about the Philippine Space Agency, the space value chain that we are following, as well as the projects that share data and produce value-added products from satellite images, and of course the various DRM applications of satellite image treatment. So this is just a quick introduction about the Philippine Space Agency, which was created by Virtual Republic Act 11363, or known as the Philippine Space Act. So this law, Philippine law, mandates the Philippine Space Agency to be the primary policy, planning, coordinating, implementing, and administrative entity of the executive branch of the government to promote the national space program in line with the Philippine space policy. So central to the role of PhilSA is value creation. It's the core of PhilSA mission, which is to promote and sustain a robust Philippine space ecosystem that adds and creates value in space for and from Filipinos and for the world. So here we highlight value creation as well as strengthening or sustaining a robust Philippine space ecosystem. This means that we have to also support the other members or other components of the Philippine space ecosystems, including the academia, including the government, other government agencies, including the private sector and the users such as the common public and so on. So the Philippine Space Agency has these 6 development areas, and the topic for today is falls under one of it. So it's the hazard management and climate studies. So the Philippine Space Agency is actually crafting a open data policy for this particular component, the hazard management and climate studies. And in line also with other KDAs, we are promoting improved public access and resource sharing, including, of course, data sharing, sharing of information and knowledge, and doing capacity building to improve the situation in the Philippines or sustain the continued improvement. So the Philippine Space Agency, together with the OST and I think also UP, collated this volume 1 of the our place in space. So this is a 3-volume book compilation. So this volume 1 on space data mobilization shows the various applications of satellite imagery or Earth observation data in the Philippines, including monitoring, of course, some areas or within the territorial boundaries of the country, EEZ, as well as our land areas, monitoring the flooded areas, as well as different various applications. This book or online book can be seen in our or downloaded even from our website. One of the, as mentioned in the earlier slide, we focus on value creation as well as ensuring that data are actually utilized in the Philippines. No? So this is a good example of use of satellite imagery by the Department of Environment and Natural Resources, and PhilSA has a memorandum of agreement with them to uh, help them in utilizing satellite imagery as well as improving capacity. So using satellite imagery together with ground reports, then this led to the busting illegal mining in the southern Philippines. So again, the goal is to ensure or help realize that socioeconomic benefit and value are realized from the investments in the space. So this includes the upstream space infrastructure through these satellites and the range of satellites that have, say we can access the data. Then we also maintain ground infrastructure for downloading and hosting the data. So the capacity to interrogate and analyze the data is continuously expanding because in particular in our bureau, the Space Information Infrastructure Bureau, whenever there's a need from, say, a national government agency, then we try as much as possible to develop methodology to address their need. For example, there's a need to monitor corn in the Philippines at various stages to examine and forecast the supply of corn from various corn farmlands. Then we are now developing such methodology. In addition to the other agricultural monitoring we are also undertaking. And of course, in order to realize the socioeconomic value and benefit, then there should be impetus and resources to act on those data sets. So one way of, say, building the space ecosystem of the Philippines is through the data sharing, through sharing these different data sets or satellite image data from free and open and even from the sovereign satellites as well as those from commercial and those activated during the disaster charter. And in this presentation, most of the examples that I will be talking about comes from Dharma, which is one of the application development projects under the DATOS. So we can see here the meaning of DATOS. The DATOS is like a continuation of a DOST ASTI status, but this time we named it as the Data Analytics Technologies and Operation Services using space data, primarily focusing on developing methodologies as well as serving those data products. So one of the projects under the DATOS is the DHARMA, or the Disaster Hazard and Risk Mapping. So this provides on-demand geospatial support before, during, and after disaster events using space data. And of course, depending on the need, so it develops rapid assessment workflows for disaster events. For example, for the case of the oil spill, so there have been some developments going on in response to that oil spill in Mindoro. So let me say something about the different applications in relation to the RRM. So the typical is the flood mapping. So whenever there are typhoons and reported flood events, then depending on the scale, we activate the Sentinel Asia or the disaster charter. In this example, this is a map showing or images showing the extent of flooded areas in the southern Philippines using Landsat 9. So these are other examples of flood mapping and monitoring. So as long as there are floods, then there are monitoring of mapping and monitoring that is being conducted by PhilSA together with DOST, in particular ASTI and in other groups even. In one of the discussions in the Copernicus Philippines, flood mapping was one of the candidate pilot projects now. So the idea initially was that, okay, even though there are no reports of flooding in certain areas, then there should be continuous processing of data. So that will be maybe the case later on if we have already fully put in place the HPC capacity of the Philippine Space Agency. But at the moment, the mapping is basically acting on the or triggered by the reports on the ground, by the postings of Facebook and so on. But whenever there are images that passes of Sentinel-1, then those are actually processed in the entire stream. So we are expanding this flood mapping into flood impact mapping, particularly in determining the areas, croplands that are flooded or impacted by the floods. At the moment, this is just a simple area computation, like an overlay of the flood extent delineation with the croplands that was previously mapped or those mapped in the land cover. But since we are also building our mapping or monitoring of croplands for rice and corn and sugarcane and other crops, then this one will be further be improved by saying that different stages of croplands are impacted by floods. So PhilSA and also the OSC are also mapping, say, landslides as well as damages. So prior to such events, there are efforts to update or map the structures such as houses and buildings. In this example, you have here in the middle the landslide delineation, as well as some areas that are identified as, say, houses. On the rightmost image, these are basically points coming from the UNITAR, based in, I think, Bangkok in Thailand. They help in identifying damaged and potentially damaged buildings brought about by Typhoon Rai. So these are just other examples of landslide mapping during Typhoon Maggie in April 2022. And we can see the extent of. So I think there will be further studies of this, such as like determining whether this can be detected earlier, those type of. And then there are also projects or ongoing research in the Philippines, not necessarily by PhilSA, focusing on landslide susceptibility due to, say, rainfall or due to earthquakes. We are also involved in mapping damages, as I've mentioned. So this is an attempt to map damages or quantify the different levels of damages using Sentinel-1 SAR coherence data, using the SLC IW burst with short baseline stuff. And we can see some good, some different levels of extent of damages and severity of damages in terms of the changes in the coherence stuff. So this is another example of that rapid mapping and assessment of damage due to Typhoon Rai using Sentinel-1 SAR data. So this has been published as I think ISPRS archives. So we can see that the red areas as well as the orange areas correlate or correspond to the damage as seen in the optical image before and after images. Okay. We also developed an equation for quantifying or assessing the damaged areas utilizing before and after images. High to very high resolution satellite imagery. In this case, we utilize the PlanetScope image. So shown here in the slide are the pre-typhoon and post-typhoon PlanetScope images. And again, those processed there, the yellow and the red are actually the damage, and yellow are, I think, the potentially damaged areas, which will serve as the say basis for saying or quantifying certain damage. In this approach, we utilize what we call the local spatial interpolation. So basically, in high resolution imagery, if you have a damaged roof, then the materials will not change. So spectrally, it will not really change, but it will change in terms of textural properties. So we decided to utilize some some form of texture measure, no, in a way, the local index of spatial articulation, such as the local brush eye, will be able to determine this. No? And changes is usually because of the differences in the reflectiveness across the different damage areas. So here we are calculating the normalized difference spatial autocorrelation, or the NDSA, which is basically just this formula Lisa 1 minus Lisa 2 over Lisa 1 plus Lisa 2. And this is the result of that normalized difference spatial autocorrelation, with the red areas basically showing areas or buildings or structures which are heavily or severely damaged compared to those in, say, orange and yellow. And then you have minimal, relatively minimal damage if you have green areas. Of course, this equation can also be applied to, say, vegetation and so on. So we have to do further analysis on this. And this illustrates the response that we undertook during of course, in collaboration with other space agencies, including NASA. So delineated oil expense were mapped from SAR imagery as well as optical imagery, as shown here now. And we have learned a lot during this period because we reviewed, of course, literature review, and because we noticed in certain, say, different satellite or SAR data, there are, say, really good conditions or incidence angle as well as polarization, which are very much suitable for detecting the oil spill extent. And then we have also read papers wherein you can estimate or map the thickness of the oil, or map at least a thicker or less thick oil. But another output coming from this experience is that we also were able to estimate the volume of oil based on thin film equation. So that will be presented in the upcoming ISPRS Spatial Week in Egypt. So learnings from this oil spill monitoring, so the data were all shared to the Department of Environment and Natural Resources, as well as to the OCD and the National Disaster Risk Reduction and Management Council. So DNR utilized these delineations in order to quantify the impact, economic and other impacts of the coastal marine environments in Oriental Mindoro. And based on this, I can say that we have to further develop the oil spill mapping such that it will be made quicker, because there are also challenges whenever you look at SAR, because some say areas with low backscatter appears to be oil spill, but they are actually not. So there should be some further improvements in the methodology. In terms of the slow onset disasters such as drought, so in this case, in FILSA, because we have Dr. Gage Paris, who has worked on this project called the Drought and Crop Assessment and Forecasting project. So these are almost an operational stage together with the Department of Agriculture. So they are able to utilize various indices to assess the agricultural drought, and even do forecasting for the next, few months. Such as in this example, you have assessment whether you have developing, say, drought or even raining, or so those type of patterns, temporal patterns, and forecast which can be severe, moderate, mild, and normal. So the Philippines, as any other country, is actually preparing for this El Nino by monitoring drought through space observation data. And the Philippines, the DOST, PhilSA, and ISA are complementing this National Copernicus Capacity Support Action Program for the Philippines. So this supports our aim to strengthen the nation's resilience to natural disasters and climate change. And based on the activities, there will be three main groups of activities. One is the establishment of the Copernicus Mirror site in the Philippines, which will serve initially the needs of the Philippines, but this will be expanded to the ASEAN region. And we have also the capacity building efforts. So this includes trainings, workshops, and scholarships, and the pilot projects. No? So out of the 7 pilot projects initially identified projects, we have finally selected the 3. So there will be a pilot project on land cover and forest monitoring, benthic habitat mapping and monitoring, and also ground deformation monitoring. And the goal, of course, for this pilot project is to eventually offer services, say, such that you have benthic and land cover mapping being conducted every 1 to 2 years, and the products will be made freely available covering the entire Philippines, and later maybe expanded to other areas or other countries even. And the ground monitoring will continuously monitor the ground deformation, vertical land movement, and this it can be also offered as a service. So the Philippine Space Agency is also working on establishing a network, such that we have a network of researchers or of, say, collaborators from different sectors, and also enable or ensure that the data that we distribute and all other data that they acquire from other agencies can be used towards supporting decisions, taking actions, and also policy formulation. So far, this has focused on several areas of application, including the agriculture, environment, and of course the RRM and climate studies. The dots on the Philippine map that you see, there are actually the areas where we have conducted our workshops, and during those workshops, we have distributed considerable amount of data for them to utilize in various planning and applications by the LGUs. And the DRM efforts, the disaster hazard mapping and risk mapping efforts of USA. So this is complemented by the use of, say, the Open Data Kit. So we promote this during our workshops, during our webinars, so that the people and even various groups can actively participate in sharing occurrences of different disasters or hazards, flood, landslides, earthquake damages, and data that they would like to report on. And this will be utilized to enhance the products or to ensure the accuracy and validity of the space data products. So beyond the just mapping, for example, the hazards and also the damages, and we also would like to continue a similar project. So this is a thesis by my master's student. This was 10 years ago, but we have to move towards also mapping the vulnerability, for example, of coastal areas to sea level rise, vulnerability of agricultural areas, for example, to flooding, to saltwater intrusion, and those kind of things. With this type of assessment, then we can also improve our response or mitigate disaster. In the Philippines, this is actually true, that geospatial data is still not being used sufficiently to improve people's lives. So there's many reasons to this, because perhaps there's lack of capacity in terms of human, scientific, technological, organization, and institutional resources. And then we have to improve the access to high resolution data, not only to high resolution imagery, but even, of course, high resolution may mean high temporal resolution of data, or even resolution of any spatial data at a particular higher disaggregation. And then expertise may be limited in certain areas, particularly in local government units where they don't have manpower. Data sharing must be improved, and appropriate policies must be put in place. So in conclusion, there's a lot of challenges to meet, not only in DRM, but also in other applications of SSTA in order to ensure that the socioeconomic benefits and value from earth and marine observation are utilized. No? So this includes collaboration, sustained research development innovation programs, education capacity building, allocation and sharing of resources, and policies and directives, and of course the commitment of everyone, including the end users in particular, to operationalize, institutionalize, and utilize whatever data are actually useful to be uh, uh, implemented within their organization. So that's all from the Philippine Space Agency. So these are our social media pages and our website and email addresses. Thank you very much.
Thank you. Anybody here have a question to Filsa, Dr. Ablang? Where is he? He gone? Are you here? You still here? Oh, up. Okay. All right. Yeah. Anybody have a question to Dr. Blanco? Maybe. Sorry, pronounced wrong. Do you have any question about that? Do you have? No? Okay.
Thank you so much, Dr. Franco. Actually, I'm not having a problem question, but one of maybe request as the disaster mitigation working group. If that's possible, once there's any open services from FIOSA, would you like to share the portal or the URL or the resources to the APAN partners? Would you like to compose some kind of list of available resources or available services to our partners? So if there's any open services from FIOSA, do you think it's possible to share the URL or the access point in the category?
Okay. So in FIOSA, we are still working on, say, data portals, especially the dashboard that we will be able to share open data sets. So that will be made available sometime in the last quarter this year. For example, there are many outputs coming from the flood delineation or landslide delineation mapping, as well as mapping land cover and tree cover, and even mangroves and coastal marine areas. So many of these data sets will be made open to the public. So in particular, those data sets that are useful for hazard management and climate studies, those will be made available. No? Of course, if there are, say, partners that are willing to collaborate, and we are open to doing such things. So, for example, we participate in the APR SAP, and then we are collaborating, or we will be collaborating in many projects under the APR SAP.
Thank you so much. As I mentioned in the first session, we try to make our case study available, including all the material from the case study. The second part of available resources, including data, services, or tools. Yeah.
When you say to the public, is it outside Philippines can also access, right?
Yeah, if it's made open data, then we put it out in our dashboard or system. It will be made available to everyone.
And this is like the data globally or data of such Philippines area only.
Yeah, because we mainly operate or map within the Philippines, unless there are, say, requests coming from other countries in collaboration, maybe for R&D activities. No? Maybe later, if we are actively participating also in the disaster charter, for example, if it's activated in Thailand, then we can actually help in mapping certain areas.
Okay. It could be like a special request.
Mm, yeah, at the moment.
All right. Okay. Any further question? Okay. If not, thank you very much. And
Very
go
much.
to the second. Please stay. Don't go anywhere. We have a discussion at the end.
Yes,
So
no worry.
we will go to the second speaker from TASA, Taiwan Space Agency, Dr. Lee Yun Chang, and we'll go in deep detail. You saw a bit about the oil detection, oil spill detection, but this will go into detail more, a lot more. So the floor is yours. Please share your slide.
Miss Xu Yiyun will be
Oh,
the speaker. Yes.
Okay.
Yeah.
Xu Yiyun, okay.
Please. Yeah.
Okay.
Share
Sorry.
your slide.
Just follow this. Full screen, please. And then your mic is still off.
易云, can you hear us?
Is it? Are you?
Hello?
Ian? Is it? Yeah, Ian.
Yes.
Okay, trying to.
Yes.
Are you there, Ian? Yes. Can everyone? No, because your mic is off. Please click on the unmute on your left, I think. Can you do it here? Can we just remotely do it? Unmute it. Oh, very fancy, eh?
Yeah, the last one.
The last one.
Yeah.
Yeah, on now.
Yeah.
But I think she. Oh, yeah.
No.
Okay, just okay. We cannot hear you. Maybe when connected, you need to select to use the. She connected. Mine, but not working. Okay.
易云, would you try again? We cannot hear you.
Well, we try to solve the problem a bit later. You can test. Now
Can you
can.
hear me?
Okay, please go ahead.
Sorry, there's a. Okay, I'll close it. Okay. Okay, can everyone hear me?
Yes.
Okay, good. So I'll share my screen. Wait a moment. Okay, I'll use this one, I think. Okay, can everyone see my PPT slides now?
Yes. Yeah.
Okay, great.
Full
Yeah,
screen.
yeah. Okay. Good afternoon. I'm Xu Yiyun. I'm the group member of Satellite Data Processing Division in TASA. In today's presentation, I'll give an introduction about the study about oil leak detection using multi-temporal satellite data. In this case, we detect an event of the oil spill area near the coast of Philippines in the end of February this year. This is my outline. First of all, I will give a brief talk about the background of this event, and then I will show the multi-temporal satellite data and the image classifier we use for oil spill area detection. And then I will demonstrate the result of this identification. In the end, there are also some discussion and the conclusion we'll talk about. In the end of February in this year, there's a oil spill event in the coastal near Philippines. Since it's a severe event, and then may
Would you hit the full slide button on your side? It's not in the slide mode. Yeah.
okay, yeah, great.
Okay. Thank you.
Okay.
Great.
Okay. Since since it's a severe event in for the environment and the health for the government, so TASA try to acquire the event derived from Formosa 5 satellites, and we also try to support the oil spill detection by using various real-time multi-temporal satellite image data. This is the area of the oil spill event. For the identification, we collect four optical image data for the image identification. The first image is acquired from CS1, and then we also acquire three other image data from Formosa 5. We use these four image data for our oil spill area detection. This PPT slide shows the fusion image data for these four days. We can find out the spectral characteristic in these four image data are different, so it make our detection become difficult. In our study, we use ISO data clustering as an unsupervised image classification for oil spill area detection. After our ISO data processing, we can identify the oil spill area by using a manual cases assessment. And now I will show the result of the identification. This is the first image data we acquired from TS1 on March 4th. In this image data, we can find that there's a severe cloud mask. It might affect the detection in our study. Here we use ISO data classifier for the oil spill area detection. Although there's a severe haze and shadow effect, ISO data classifier calculate the area of the polluted is around 2.7 kilometers square. But since the cloud mask effect, the result may not be so completed. Yeah. And this is the second image data we acquired from Formosa 5 on March 6th. We can also find a strong cloud mask in this image data, so it might also affect the result of identification. Then we use ISO data to identify the area for the polluted. The area of the calculation is around 3.5 kilometers square. And then this is the third image data we acquired from Formosa 5 on March 8th. We can take a look at this image and found that there's a severe severe sampling in this image data. So it may also affect the result of identification. With the ISO data classifier, we calculate the polluted areas around 4.4 kilometer square, and this is the last image data derived from Formosa 5 on March 10th. Also, there's the severe sun glint, so it may also the direct reflection may also affect the result of our detection. With the ISO data classifier, the polluted area is calculated around 11.39 kilometers. And if we overlay the result of these 4 image data, we can find that the oil polluted area enlarged day to day, and due to the effect from sea wave and current, we can find that the air polluted area move gradually. The result of the oil spill area detection was uploaded to Sentinel Asia server, and this is also the result. And we also get some feedback from the Facebook of FIOSA. In this case, since the complicated interaction of the solar angle and the sensor view angle make our oil spill area detection become difficult. In our case, the cloud mask and the shadow and the sun glint may also make our image data different a lot. So it makes our detection become challenging. In this study, we use ISO data and manual cases assignment to identify the oil spilled area. Despite that the spectral characteristic in each image data changed a lot. Due to the sea wave and the current, we can find that the thickness and the velocity of oil slick decrease, and this also make the polluted area become larger and larger. Due to the enlarged oil polluted area, this may also make the environment protection become difficult. The result of our oil spill area detection were also uploaded to Sentinel Asia, and we also get some international feedback. Thanks to the organization of Sentinel Asia, we can not only acquire optical image data from Formosa 5 satellites, we can also get much more sensor data, which also support our identification. In this case, we got temporal image data from Formosa 5 continuously. This also make our detection become much more real time, and we can also observe the temporal variation of the oil spill area. Since the oil spill area detection is difficult due to the difference in multi-image data. So we use an integration of manual and automatic image process for emergency analysis. And according to FIOSA, and the international collaboration supply image data sharing efficiency, and it also make the disaster event can be reported rapidly. This is our study for the remote sensing data, and if we also have much more analyze about remote sensing data by using data queue. Actually, it will be a training workshop next year on APAN 57. Will give some tutorial about how to use data queue as the open source environment for the remote sensing data analyze. So if anyone has are interested in how to use this open source environment, you can just join the tutorial next year for APAN 57. So this is my presentation. Thank you.
Thank you. Thank you very much. So you're coming next year for sure in
Yeah,
Thailand.
yeah, we hope so. Yeah.
Great.
Yeah.
Great. Okay. Any further question from the analysis, please?
Thank you for a wonderful presentation. I have actually just want to seek a question, or you can say this gather to knowledge or your opinion in a two ways. Number one, the one point is that have you tried with the images from the different satellite? You have used one satellite. Have you tried to get the results and to find a difference between that the images is gathered from a different satellite? Secondly, you worked on the image classification. Obviously, it's very good technique. But have you tried with the try to create any index for the oil detection, and with the help of the different bands available? That may, in my mind, that may help if we have come up with a new index. Actually, that might help to the other countries as well to simply apply that index on the satellite data and to get that any leakage or seepage from in the sea. So these are the two things that I'm interested to know. Thank you.
Thank you for your question. And in our case, we use two remote sensing data from TS1 and Formosa 5. But actually, I think in this case, since it may be some affected from cloud or climate from weather. So actually, maybe we can also consider about use SAR data as another remote sensing data source for the analyze, I think. And since the various remote sensing data will supply different bands of different optical bands for analyze. So in our case, we only just use RGB NIR as our analyze, but I think much more bands will also support all this analyze, I think. Yeah.
Okay. Any further question regarding the oil spill? One thing then, because of the oil spill, do you try to use the microwave sensor to detect it? Because usually it's a microwave is good for oil spill.
Yeah, we also found that since you can find in our image data, there's a strong cloud mask or sun glint email. I think it will also affect the result of our identification. Or if we want to use other AI RN kinds of AI mode, I think this the difference in spectral characteristic in different image lips may also affect the result of our identification.
Okay. Thank you. Okay, then if not, we move to the third speaker, also from Philippines, ASTI, Dr. Adrian Dalakas. The topic will be understanding lightning and thunderstorm for extreme weather monitoring and information sharing. Please, the floor is yours.
Hi everyone. Before anything
Could
else,
share the screen.
just want me clearly.
Okay, you could share your screen, please.
Okay. Could you hear me clearly?
Yes, we can hear you, but you're not
Okay.
sharing your screen. Oh, okay.
Screen is
So,
already visible.
all right. Okay. Yes,
So
the
hello.
floor is yours. Yes.
Thank you. Hi everyone. Sending a warmest afternoon all the way here in the Philippines. Again, I am Adrian Deliagas from DUST ASTI of the Philippines. So I'll be presenting to you the Understanding Lightning and Thunderstorms for Extreme Weather Monitoring in Information Sharing, or commonly known as the ULAT project. But before I go on to discuss ULAT, short background about our agency. DUST ASTI, or DUST Advanced Science and Technology Institute, is one of the research arm institutes of the Department of Science and Technology of the Philippine government. Our primary mandate is to take research and development in the field of information communications technology, or ICT, and microelectronics, and we also deal with space technology. The Philippines is known to be the typhoon nest in the Western Pacific region and one of the disaster-prone areas or countries in the world. Our location in the Pacific Ring of Fire greatly contributed to being highly susceptible to natural disasters. Notably amongst these disasters are typhoons that bring massive devastations to the lives of Filipinos in general annually. This slide shows the trajectory of typhoons occurred from 2011 to 2016 alone. According to DOST, Philippine Atmospheric, Geophysical and Astronomical Services Administration, or DOST Pag-asa, which is the mandated Weather Bureau of the Philippines, an average of 20 tropical cyclones entered the Philippine area of responsibility per year. And recently, we have seen and felt stronger typhoons that sometimes became and turned to a super typhoon. Aside from this, the occasional monsoon and other weather disturbances also lead us to experience widespread and frequent flooding. The country also loses billions of pesos in infrastructure, agriculture, and economy due to typhoons. An example is during the aftermath of the recent Typhoon Doksuri that hit the northern part of Luzon Island in the last week of July this year. Philippine authorities estimated a 5.9 billion pesos worth of damage, 4.4 billion in infrastructure, and 1.5 billion agricultural damage. Here are some images that display how the typhoons are in our country. The first one was after the rampage of Typhoon Rai, or Odette in local name, in Visayas region, that left thousands of Filipinos homeless in the week of Christmas last 2021. The second one, when Typhoon Bangko, or Ulysses, put the Cagayan Valley region under the flood in 2020. And the last one, when Catanduanes province faced the raging 220 kilometers per hour winds of Typhoon Goni, or Rolly, in 2020 as well. Such these scenarios push our government to continuously invest into several research projects that will combat the effects of climate change and improve and aid the current disaster response system of the Philippines. We definitely do not have the capability to change the tracks of these typhoons, but we can do something to make us prepared and mitigate the effects of them that cost the lives of many. One of the initiatives that we are doing is studying lightning occurrences for weather analysis and eventually for weather forecasting. Some studies suggest that lightning may signal changes in the organization and development of a storm. Two studies way back in 2005 and 2007 showed that there is a strong correlation between lightning occurrences and weather events such as change in maximum sustained winds that may signify the arrival of typhoons with a lead time of 1 to 2 days. Having the knowledge from those studies, professors from Hokkaido University in Japan and Japan International Cooperation Agency or JICA, under their Science and Technology Research Partnership for Sustainable Development or SATREX program, collaborated and partnered with DUST ASTI in 2017 to give birth to a project that will collect, gather, and analyze lightning occurrences all over the Philippines to hopefully use it for weather forecasting. During its inception, the project was named as Development of Extreme Weather Monitoring and Information Sharing System in the Philippines, and then later was popularized as Understanding Lightning and Thunderstorms for Extreme Weather Monitoring and Information Sharing, or ULAT project for short. DOST ASTI also collaborated with DOST Pag-asa as country's weather bureau and University of the Philippines Institute of Environmental Science and Meteorology, or UPISM, for the implementation of the said project. ULAT project main framework is to study the country's weather behavior by correlating lightning occurrences with extreme weather disturbance such as rainfall and typhoon intensity. The project sets 4 major objectives to be accomplished. First is to establish dense and nationwide lightning network. This is where the deployment and installation of lightning detecting stations comes into place and shall serve as the ground-based system to collect and gather lightning data. Japanese professors identified the critical areas, especially with nationwide lightning network, were ideal to put these stations. They designed it in a sense that it will cover all areas of the country. Second objective is to establish satellite 3D cloud monitoring system. And in order to achieve this, a ground receiving station shall be put up to receive images from Philippine microsatellite Diwata 2. These images, specifically cloud images, will be reconstructed to extract more information for further weather analysis. Because according to Japanese experts, clouds contain so much information about weather. This system shall serve as the atmosphere-based system for weather analysis, complementing the ground-based system composed of the lightning detecting stations. The third objective focuses more on the end goal of the project, which is to hopefully develop a short-term forecast. The target is to give a forecast at least for the next 3 hours within approximately the 5-kilometer radius where a station is located. Lastly, the fourth objective deals on how these gathered data and valuable outputs will be put on use by the public. A website shall be created and shared to vital government agencies such as DUST Pag-asa and other entities, specifically those who are in the front line of implementing disaster response and mitigation plans in the country. Agencies not only limited to national agencies, but it shall also be extended for the use of the local government units or LGUs. Researchers from different sectors and academia here in the Philippines shall also be allowed to use the gathered data for their own studies and feasibility plans. Under the first objective, we are technically deploying 2 types of stations, Pipoteca and Vipoteca stations. Pipoteca station is used for dense lightning network. It utilizes plate sensor to detect lightning events. It is also equipped with multi-parameter sensor for reading weather parameters such as temperature, air pressure, wind speed, and wind direction, and a rain gauge sensor for measuring the rate of rainfall in an area. The station will function on its own even without an external power connection, since it has 2 lead-acid batteries and 50-watt solar panels to support its power system. For this network, we are usually partnering with LGUs, academies, and private sectors within the National Capital Region of the country. A Memorandum of Agreement, or MOA, binds DOST ASTI and the partnered entity to allow us install the station within their premises. Stations are separated at least 3 kilometers away from each other to somehow make sure that all areas of Metro Manila will be covered. 50 stations were initially planned to be deployed. However, due to some factors, notably the COVID-19 pandemic, prevented us to do all sorts of field works for more than 2 years. Only 43 stations are installed at the end of the project implementation. Here are some photos of the Biblioteca installations we conducted before in different areas in NCR. And even the project initially ended last March 2023, we are still continuing to deploy remaining Biblioteca stations under this network. And recently, we have an ongoing effort to install additional sensors such as field mill and infrasound for Biblioteca stations. This was initially planned during the early years of the project. However, due to pandemic, shipment of these sensors from Japan was continuously put on hold and only arrived here in the Philippines this year. These two sensors are also to be utilized in the collection of lightning data. A field mill measures electric field in an area, and with that could be used to locate within the system where there is a possible thunderstorm. Meanwhile, an infrasound used to measure sound waves emanating from the thunderstorms. Only 10 selected Pipoteca stations will have field mill sensors, while infrasound will be installed in all stations in the dense lightning network. On the other hand, Bipoteca stations is what we deploy under the nationwide lightning network. It has same components with Bipoteca station aside from its lightning sensor. This station detects lightning using a VLF antenna, an antenna that senses the VLF frequency generated by a lightning. A total of 10 stations were planned to be scattered all over the Philippine archipelago and will be put up within DOST Pag-asa regional offices. At the end of the project implementation, 8 Bipoteca stations were successfully installed, and just last month, 1 station was added to the network. The remaining last one is scheduled to be installed next month. So by the end of 2023, the planned 10 stations will be completed under the nationwide lightning network. Here are some pictures of the deployed Bipoteca stations. As you can see, they are elevated by 1 meter to protect them from potential flooding. Our team also conducts routine maintenance for all installed ULAT stations at least once per year for its sustainability and also to make sure that they give accurate data. During the visit, we clean the stations, remove obstructions that could hinder the operation of the station, and change its batteries every 2 years. Moreover, we also make it a point to visit a station after an inclement weather such as typhoon and natural disasters such as volcanic eruption for a physical checkup and thorough cleaning. Other instances to visit a station are first, when we observe irregularities on the data it transmits, and second, when our stakeholder requested for a pull-out or relocation of the station, mainly because they would have a future development plan in the area. Other than that, our stations don't need to be checked and visited regularly. This is the system architecture and data flow of ULAT. As of now, the default sending time of our station is every 1 minute through 3G technology. But we have plans to upgrade it to LTE technology. They send data both to a server in Japan and in our server here at ASTI. Then our team is currently developing a website wherein users can view the data coming from ULAT stations. This website, which is still in the development stage, will show geolocated lightning, weather, rainfall data, and we also target to integrate the forecasting part on that website. Later in the presentation, I will show to you some images of the ULAT website. For now, we decided to integrate the ULAT data to the ASTI's field sensors website for our stakeholders who may wish to have access to for monitoring purposes. ASTI also offers API access for research entities here in the Philippines who want to use ULAT data for their research. So during the early stage of our research for the collected lightning data using the nationwide lightning system, our team explored different algorithms for lightning geolocation. These were grid table method, hyperbolic method, and circular method. These 3 algorithms use different time difference of arrival or TDOA process. For grid table method, this algo generated points with pre-plotted locations for the whole Philippines with a resolution of 0.01 degree or approximately 1 kilometer. Then after processing the different time arrival of lightning, the closest point where the lightning takes place would be its location. Meanwhile, both circular and hyperbolic method present an equation, and out of that equation, station would generate either a circle or hyperbolic. The intersection of three or more circles or hyperbolics generated by multiple stations would be the location of the lightning. Among the three, we decided to use the hyperbolic since it is the one who presents great results. Here are some of the initial results we produced using the three different algo during the devastation of Typhoon Nuru, or which is local name Typhoon Karding last September 2022. The light blue with triangular shape are the installed Bipoteca stations, and the clustered red dots that you can see in three images are the geolocated lightning data recorded all over the Philippine archipelago during the time Nuru hit the country. For dense lightning network, there is an ongoing validation and processing of lightning data using Bipoteca stations. So our team is still to produce a geolocated lightning data output for the dense lightning network. However, our partner Japanese professors had already produced and presented geolocated lightning data outputs using their own algorithm. Image on left with cluster red dots implies the geolocated lightning data using the Nationwide Lightning Network or Bipoteca stations. While the two images on the right, the X indicates the possible location of a lightning within the dense lightning network or Bipoteca stations after processing it. So for us, we could use these results of the Japanese to get an idea from and base our continuous development of the geolocated lighting data using Bipoteca station. Meanwhile, this slide shows the initial results concerning to rainfall data collected by our station. On the left is a visualization of rainfall brought by Typhoon Bongfong, or locally known as Ampu, in May 2020. And on the right is plotted rainfall data sent by ULAT stations last August 5, 2022, which was generated using the ULAT website. With regard to the second objective of the ULAT project, we already established the ground receiving station with a 3.5-meter Earth observation satellite tracking antenna located at Dumangas Climate Field School, Iloilo Province. It was inaugurated last March 2023 with representatives from JICA, Hokkaido University, DOST, Philippine Space Agency or PhilSA, and local government unit of Dumangas. The GRS is now fully operational and continuously collects images from Diwata 2 that will then be subjected to further analysis for a much deeper understanding of clouds and extracting information out of it for weather analysis. This is the previously mentioned ULAT website that I am referring to. Again, this is not yet for public use since the development is still on progress. The image on the left shows the map view of the website wherein you can choose the different weather data parameters you want to view. And instantly all the stations will show their specific data. On the other hand, the image on the right shows the different weather data if you opt to view them in graphical form. We also plan to integrate to this website the geolocated lightning data and hopefully the forecast output of the said project. For greater appreciation, I took screenshots of the weather parameters you can view on ULAT website and how they would appear. First image on the upper left tells you what kind of weather does a station have. Second image on the upper right gives you the temperature measured by each station. Lower left image is for showing the heat map, and the last image on the lower right is for rainfall measurement. Section for viewing lightning data is separated, and there will also be select button for historical lightning occurrences. We also decided to add the housekeeping data on the website. This is for easy monitoring of some parameters of the station that affect its overall operation, such as signal strength and battery status. Using this, we could identify and know the possible reason if it encounters an issue. As previously mentioned also earlier, we already integrated at least the weather and rainfall data of ULAT stations to ASTI's Field Sensors website for those who may wish to view it publicly. Field Sensors website contains more than 2,000 stations, some of which are hydrometeorological stations. Once you visit a station on Field Sensors, it will give you a real-time weather data of it. You also have the liberty to download the real-time graphical data only of the station in any format you want. There is a tabular section as well if you want to view the stations in tabular form. The pictures in the slide show the dense lighting network and a sample of real-time rainfall data of a station. Same goes if you want to visit a station under the nationwide lightning network. Our team also presented and published 4 different papers on various international conferences under ULAT. These papers and the opportunity to present them give us an avenue for wider audience and global audience to disseminate and show the initiatives we've done under the project. So here is the list of our published paper. I believe that's the end of my presentation. Thank you everyone for listening and have a good day.
Okay, thank you, Dr. Adrian. Anybody have any question on this? Look very nice, promising. Okay. I have one question then. For the GS map, there are also a rain product from the GS map by JAXA. Are you planning to use that, combine that into what you are doing now to see the rain intensity?
Yes, sir. Actually, aside from lighting data, we are also producing or showing the rainfall data of ULAT stations, whether may it be on a Field Sensors website or in API access that we give to our users.
Okay. Okay. Yes. Bazuki.
Okay, thank you. Very nice work. What is the sensor for the lightning in the weather in the AWS weather station? What is the sensor of the lightning? Is come from the from the weather satellite, or in the there is a sensor in the weather station?
For our station, sir, for Pipoteca, we use plate sensors, basically two plate formed together. And for Vipoteca station or for our lightning nationwide um, nationwide lightning network, we use VLF antenna to detect the generated VLF frequency of the lightning. So we have two separate or different lightning sensors that we use for our stations.
Okay, you collect all the when there is the lightning, and then you the sensor is up and record and send the data to the server.
Server, yes, sir.
Is that right?
So yes, sir. Every 1 minute, our station send data to our server.
Every minute you send the data? Or...
Yes, sir. Every minute, both weather and lighting data.
Okay. Is there you mentioned in your presentation there is an API server? Is that
yes, sir.
This API can access through to other country? I mean, like in area, yeah.
As of now, sir, our Philippine users could access the data from our ULAT stations first through field sensors. They could view it. They could view the rainfall and weather data of our stations on field sensors. And for lightning data, if they want to have an access to it, they could request or we could give them API access. They only need to accomplish end user license agreement or EULA. But for international users, sir, I'll still confirm to our team regarding that. But they can always send a formal letter of request to us regarding ulat.
Okay, okay. Thank you.
Yeah, one more question, please, from Eric.
Is it possible to have prediction, for example, in the next few hours in some certain areas, what's the probability to have lightning? Is that possible?
As of now, sir, for forecasting, I couldn't show to you any concrete outputs for this one since we are currently in the early stage of the development. We are still validating the algo to use, such as whether it be CNN or LSTM, and would present great results. We just started processing or focusing on this matter last 2022 since we had difficulty hiring staff fit for the job. And also, our Japanese counterparts are continuously processing and developing the forecast output of the project. But according to them, to their initial study and results presented to us, the results are promising. But as of now, we don't have still the forecast output of the project. We are still developing it.
Thank you.
Okay, thank you. Thank you very much. And probably we run out of time, so gonna come to the last session about the discussion, the regional collaboration. Please, Eric.
Yeah, thank you. Just a summary about the regional collaboration, and so that we can have discussion about the arrangement for the next event and in the future. As I mentioned, that case study, according to our experiences in the past few years, is quite useful for the resource sharing and also collaborations. So for now, we've been conducted almost 20 case studies in terms of the type of hazards. We have tsunami, typhoon, dust transportation, flood, the forest fire, and also the lightning. So for each type of hazard, we also have leaders, domain scientists leading the case studies. So for example, Dr. Chai is in charge of the wildfire monitoring. And now we have a new case study that's about the lightning. I think Asti Friends and his colleagues will be the leader. And in the future, we hope to see more case study about the health related, as presented in the first session. The other thing is about the deeper understanding approach. That means for each cases of the hazards, we like to identify, to understand the science, the physics behind the hazards, so that we can improve the numerical simulation tools, so that we can quantify the risk and to reduce the risk factors accordingly. That's the way we conducted the case study. Here is a simple workflow. According to the 2 sessions, I made a brief summary that apparently, as you can see, that the collaboration actually involved, we need domain scientists, the service provider, and the user community at least. So together we can demonstrate the impact of the risk analysis works. So in the meeting today in Sri Lanka, we have new topics. The health related cases are presented by Philippines and also Japan. They mentioned about the key issues to improve the risk mitigation, such as the infrastructure, the practices, the building of the trust framework, interoperability, and also how to run in the sustainable supporting framework, etc. For the Earth observation related data, we see many supported cases, including the disaster risk management and also those oil spill cases, monitoring and analysis, and of course the lightning. And it's a very good that the special agency in Philippines and also Taiwan, I believe also in Thailand, they are also very happy to share the satellite data and services. So we hope that in the future, maybe we could have another category of the case studies that's making use of the satellite data to improve the risk analysis. And of course, as we learned from other space agencies around the world, there's a trend. Open science is one. The digital twin is another. Maybe we in the future events we can have some experts talking about these two things. So in APAN 57, Dr. Chai mentioned that he already contacted the, I stole from your slides. Yeah, Dr. Chai already talked to, UN Spider, GISTA, and also JAXA peoples. The idea is to have a master class in the next APAN meeting in Thailand. So the topic is about disaster mitigation. Yeah.
Yes.
In the past, we've been conducting 3 master class in Indonesia and in New Zealand.
New Zealand.
Yeah, and other places. So we hope next in Thailand we can have another master class, especially focusing on the disaster and risk.
Yes, it's gonna be like that. But probably I will also ask NASA and NOAA to provide something.
Another proposal from the Space Agency of Taiwan.
Yes.
You can see from the slides. They propose to have a 3 hours, including hands-on sessions, how to making use of the Open Data Cube systems to easier use of the satellite data to improve the analysis and the applications. Yeah. Yeah. So from these 2 proposals, I think at least we need a full day for the master class.
The problem thinking that maybe more than a day. That's the problem. But we'll see about that, because with the list of for even UN Spider, they do it like a day already, or they could do it a week or something like that. So it's gonna be discussion about it. I told them that have to be here for APAN 56 first. So we talk in the session, and then I'll push and let them know that okay, this is on, something like that. It's already discussed previously, because I saw that the UN Spider organized like 5 days workshop at the UN SCAP last year.
Yeah.
So they can do it. The thing is, who can get involved? We'll think about that. Now we have, I think, more than enough, actually. But if we could get a good, like for example, we can get NASA firm to show the new capability, or the guy like Martin Wooster in UK that handle the satellite in the Europe to do things, to come and show it, would be nice. But I have to talk to them first.
Yes, we still have time to have to enrich the program for the master class,
So this,
and also
this
to finalize the
plenary, we can tell that this is our plan.
Yes.
Then I can start negotiate with them to add more and add the list.
And of course, your comment and suggestion are very welcomed.
Yes,
including the participant here and also online. Yeah. Do you have any suggestion for the arrangement of next APAN meeting, and maybe the disaster mitigation working group meeting in the future? Yeah.
Anything?
Yeah. Yeah, I think if I think if the hands-on for the like from the TESA or from the NESA about the about the how to collect the data or how to manipulate or analyze the data. Yeah. I think it's very very important. And then when this is maybe takes one days full. Maybe if possible, maybe extend to 1.5 day, because I think it's not easy for the tutorial to hands-on, because when we get the data from the satellite, it's one how to how to collect, how to when this is something like a tricky way. Then even I think NASA something have some online tutorial. Everyone, but sometimes it's difficult to us to if we didn't have if we didn't have something like, okay, this case like in South Asia example of study, maybe we can know better about this tools, because like tutorial in the NASA is mostly in the US. Sometimes it's different. It's difficult to imagine what's happened in that area. But when we have some case study around the Asia, like wildfire and lightning and everything, I think it's maybe more attractive to many people to use these tools. Thank you.
I believe it's possible to have, for example, 2-day program for us. Yes, in Thailand. Yes. Yeah.
The range of the room will be like chaos. So.
No, because next APAN is you are so that's why you can manage.
That's right. Yeah, that's the try. That's the representative of the host.
Yes, it's right.
I agree. Yes. Proposal accepted. Yeah. Half day for TASA training.
Yeah, that's the thing. That's no.
We will work for we will work for the other half day.
As another idea that I would like to highlight, that it is possible that for the workshop we can design or we can finalize the theme as well, because when you talk about the disaster, so obviously we have to use different types of data from different sources for different things. For example, one will be interested in only satellite data for the agriculture, one may be for the water bodies, one may be for the urbanization, one may be for the deforestation, one may be for the we may must say that the rains, thunderstorms. And so it would be thinking that we might for actually we were talking about, because covering all the things in a single workshop from a different data sources might be a challenging. So we can even distribute the system in the theme as well. The first session for the imaging, one time for the agriculture, second for the forestation, third for the water bodies, and then so on. So this is one of the audience as well. And
you're right. Exactly. That's a very good idea. But the problem is that once there's a concrete request for types of the hazards, then we have to look for the right person, the domain scientist, to join. In our experiences, that for each case study that takes a couple months. For the case study, the first thing is to collect the right data, which could be used for analysis. That also involves, for example, many different agencies. It's not sometimes that takes another time. Big efforts.
For the disaster, you see the name Laurent Cassan is the one that triggered the disaster charter for the world. So for that, he probably can get people if to fill in any disaster, anything that the disaster charter, international disaster charter doing it, probably can find someone.
Yeah.
Yeah.
So the working group welcome the comments or suggestion for the new case study. As what we did, there's a health-related topic might be interested to many partners. So we can look in for the right scientists, the expert, join us and start the discussion how to conduct a new case study from which one or what is the right case study to do at this moment. Yes. Yeah. That's a very good idea, but
Any
that will be
comment
a
from
starting
online?
point for new case
Yeah.
study. Yeah.
Online, any comment or any suggestion?
Even during APAN meetings, we welcome the discussions by emails among the partners to finalize the idea for new case study or to coordinate the activities in future APAN, etc. Yeah.
Any additional further comments from the online participant?
Hi, Eric. I think these possible activities for APAN 57 are great. So one could be a workshop by TASA, another one by UN Spider. So we just keep on communicating. And in my other reply, I even suggested possibly localizing some of the activities. There can be some minor activities that can be done beforehand, before the actual activity on APAN 57. And then depending on the country, several institutions can co-support the pre-work to be done before APAN 57.
Yeah, the funding would be something as well, because you have to, pay for people to come. So that's gonna be another thing.
That's true.
Yes. Any further suggestion, comments? Well, if not, Eric, please just close the session. You're the chair.
You're the chair.
Okay. Well, okay then. Thank you very much for everybody to attend the session, and hopefully we can do something more just more useful, just say, for the next APAN 57. But we afraid that getting too bigger and we'll see. But we'll see, because the main thing is the funding that you need to try to get, so many people can participate at the APAN 57 during APAN 57 for the masterclass or the workshop. Okay. Thank you very much. Thank you.
Thank you.
Thank you.
Thank you, everyone. See you in Thailand, Chai.
Maybe you're not coming. They have a CEOS plenary in Adrian, please. You have just clapping. But the CEOS plenary in Chiang Rai this November. Do you know about that? They will have it in Thailand. A CEOS plenary.
All right.
Okay.
Thank you, everyone. Bye.